Hi guys, and for the third lecture of chapter 13, we're going to be talking about the ozone layer, where ozone is good, where ozone is bad, and how some of the pollutants that we've emitted into the atmosphere over the years have actually depleted the ozone layer, as well as the success story of the ozone layer's recovery. So before we get into the ozone layer, it might be useful to talk about what ozone actually is. Ozone, or O3, are three oxygen atoms bonded together, chemically bonded together, and it's basically a colorless, unstable, and very toxic gas. So it has several notable characteristics. First and foremost, it's very pungent. It doesn't really have a color, but it smells really strongly, and it also has powerful oxidizing characteristics, which is another way of saying that ozone is very, very reactive, and this comes from its unstable properties. So ozone is formed when oxygen molecules O2 split and are recombined via different electrical pulses, and this can come from UV radiation or from different electrical impulses. Basically, as long as it has an energy source, we can split O2 apart, and then essentially that one of those rogue oxygen atoms will bond to another O2 molecule to form ozone, or O3. Now, it differs from the chemical composition of a normal oxygen molecule in that it is O3, not O2. So it has three oxygen atoms bonded together instead of the normal two. And this third oxygen molecule, or this third oxygen atom bonded to the rest of O2, makes it very unstable. It's not a stable chemical structure, and that basically that extra oxygen atom really wants to split off again and find a more stable component. Now, the reactive and unstable qualities of ozone actually makes it really useful up in the stratosphere, where it's not really readily in contact with us. Basically, all of the oxygen molecules and the ozone molecules in the stratosphere are constantly in a flux of reactions. So basically, UV radiation will split oxygen molecules apart. That O2 molecule gets split apart, and then these rogue oxygen molecules will then attach to other oxygen molecules in order to form ozone. Once the ozone is formed, they will then eventually come into contact with other ozone molecules, causing them to split back off to form oxygen molecules and then generating thermal radiation. So it essentially is taking UV radiation and then in an indirect way converting it into thermal radiation, where it's not nearly as harmful to us. So essentially what the ozone layer does when it's up in the stratosphere is buffer harmful UV radiation and keeps it from hitting us way down on the ground. However, that same reactive property that ozone has in the stratosphere is very harmful in the troposphere. Basically, when we inhale a very reactive chemical, those extra rogue oxygen atoms that are attached to ozone will try to react with components into our lungs and cause cancer or other severe detrimental effects that can really hurt us. So ozone is very good in the stratosphere, but very bad in the troposphere, where we can inhale it and it can damage us. So we just talked about how stratospheric ozone specifically will transfer UV radiation into thermal radiation, where it's not nearly as harmful to us. But essentially remember that ozone in the upper layers of the atmosphere react with the sun's rays to convert UV radiation into thermal radiation and prevent that UV radiation from affecting us. Specifically, the ozone in the stratosphere is known as the ozone layer, and it is the primary means for protecting us from UV radiation. Now, the ozone layer in the stratosphere, again, is good in the stratosphere because it doesn't come into contact with organisms. Normally, no organism can survive the oxygen limitations above the troposphere, so you don't really see any organisms living in the stratosphere, and so the ozone layer never really comes into contact with organisms. However, through the reaction that we just talked about, it will come into contact and readily reduce the amount of UV radiation, specifically the amount of UVB radiation that comes into our atmosphere and eventually hits us as organisms on the surface. So the stratospheric ozone is a very good thing. Now, it also should be noted, and this is going to be a question on your exam, that the ozone layer does not do anything with regards to climate change. The ozone layer specifically results in converting UVB to thermal radiation. It is not a greenhouse gas, and it has nothing to do with the greenhouse effect. This will be a question on your exam, as well as a question on your quiz for chapter 13. You need to know that the ozone layer is completely separate from the factors that contribute to climate change. So with the importance of the ozone layer in mind, it's useful to note the different ozone depleting substances that we have emitted in the past as pollutants that can actually destroy ozone. The first and foremost, halocarbons are human-made compounds that are formed when hydrocarbons react with fluorine, chlorine, bromine, or any other halide group. And specifically within halocarbons, you have what are called chlorofluorocarbons, or CFCs. Now, this is a harmful pollutant that is used typically as freon for refrigerators. It's used in fire extinguishers, as well as different aerosol sprays and cans. Now, the reason that chlorofluorocarbons are so reactive and so detrimental to the ozone layer is twofold. The first is that they have very long residence times. Recall from your previous lecture that anything with a long residence time has very wide-reaching long-term effects simply because it stays in the air for a very long time. The second is that chlorofluorocarbons act as a catalyst which rapidly break down ozone into other substances. Basically, they will react with they will release a chlorine atom. And once they release the chlorine atom, they will readily degenerate the ozone into a separate substance, a chlorine-oxygen molecule. After this is done, they can readily re-react with the chlorofluorocarbon again and repeat this process over and over again. So basically what happens is that once chlorofluorocarbons release that chlorine atom essentially facilitates a chain reaction. In fact, one chlorine atom can result in the degeneration of over 100,000 ozone molecules. So it's incredibly reactive and incredibly destructive to the ozone layer. And so our addition of these pollutants into the atmosphere literally created a hole in the ozone layer. Basically, these chlorofluorocarbons concentrated and formed a literal hole where there was completely devoid of ozone in some of the poles of the planet. So you can literally see this on your screen on the right. As we continued to emit these harmful substances, a hole literally formed in the stratosphere that was a weakness in the ozone layer. And this has severe impacts. Remember that the ozone layer buffers a ton of UVB radiation. If the ozone layer was no longer there or completely depleted, we would have increased rates of sunburn, cancer, and all sorts of harmful side effects of excess UV radiation. Basically, things that no other organism has evolved to buffer because we've always had that ozone layer and we've evolved with that ozone layer present. However, this is actually a good news story in environmental science in that scientists picked up and noticed that the hole was forming rapidly in the ozone layer and immediately took international action. This action resulted in what was called the Montreal Protocol. The Montreal Protocol, which was developed in 1986 and 1987, was basically an agreement where 196 nations across the globe agreed to cut the chlorofluorocarbon production by half by 1998. Since then, we have significantly reduced the emission of chlorofluorocarbons into the atmosphere, and we've basically shifted from the use of chlorofluorocarbons to safer alternatives that don't actually deplete the ozone layer. And since then, the size of the ozone hole has leveled off and completely flatlined to where it's no longer getting bigger, and more recent data suggests that the ozone layer is finally beginning to heal itself now that we are no longer emitting these chlorofluorocarbons into the atmosphere. Basically, the Montreal Protocol was an enormous success story in environmental science. But that is everything that we have for the ozone layer lecture. I hope you guys have enjoyed the ozone layer lecture, and I will be talking to you for the last lecture in chapter 13 on the indoor air pollution and acid rain deposition. All right, I'll see you then.